Identify geometric sequences. Example 1. Is the sequence shown in the table a geometric sequence? If so, write a recursive definition for the sequence. First of all, let me take a pen here. And what we are looking here, we are looking to find a common ratio. If it has a common ratio, it means it's a geometric sequence. For example, if we are looking between 4 and 12, how we can generate this term of the sequence? For example, if we multiply by 3, the common ratio is 3. If we multiply the previous term of the sequence by 3, 3 times 4 is 12. 3 is a common ratio. Now let's see, does it satisfy this other terms of the sequence? For example, 12 times 3. 12 times 3 is 36, so it satisfies. Now we are looking for the next term. For example, we multiply by 3. We're looking. 3 times 36 is 108. And now we're looking for this term here. Does it satisfy the common ratio 3? If we multiply 3 times 108, we get 324. So this is a geometric sequence. And now we are looking here how did we find those terms? We found it this way. For example, A2 is equal with A1 times 3 times 3. A1 was a 4 times 3 is a 12, equal to 12. So that's how we can generate every term of the sequence. We can find by multiplying with a common ratio the previous term. So now if we look, for example, A3 was A2 times R, A2 times 3, and A2 was A2 is a 12 times 3 is equal to 36, and now we wanted to define the recursive definition of the sequence. How did we get to this? If we write more in general and we write a finite, for example, term, and let's say an is a finite term, we can find it this way. First of all, we are looking for the first term. What was the first term? First term was of the sequence was 4. So here was a 4, and number of the terms was in the number of the terms first term. So when it was the first term here and was 4, and now we look in how we generated. We generated by every term can be generated by multiplying 3 with the previous term. So the previous term of the final term is n sub n minus 1 times 3. So this is a scenario that can describe the general form, how we can find, or the general form of the formula, recursive formula, how we can generate each term in this case. But if we need, for example, to find out for any case that works, we don't care is the first term 4, 5, 6 or whatever, we can write the general definition of this geometric sequences for the recursive recursive formula. We can write this way. We don't know what is the first term. Can be any term. Because it can be any term, let's write A1. And here we don't write n is equal to 1. The number of the term is 1. And as I said in the beginning, to generate any term, we have to multiply the previous term. The previous term of a final term is a sub n minus 1. And multiply not by 3, but the common ratio, which is r. And the common ratio, we can find it in other way. If we are looking in more sophisticated way, we can divide any term with the previous term. For example, 12 divided by 4, we get 3. 36 divided by 12, we get 3. 1 way divided by 12, 3, etc. But each one of them has to give the same result. And then we can conclude that is a common ratio and that is a geometric sequence.